Forget everything you thought you knew about learning. For most of us, the word brings to mind long nights of memorization, endless repetition, and the pressure to prove how smart we are. But what if I told you that learning isn't about cramming facts into your head, and intelligence isn't a fixed trait you're born with? The truth is far more exciting. Learning is a biological process deeply tied to the way your brain rewires itself with every new experience. And once you understand the science behind it, you can unlock abilities you never thought possible. Let's begin with one of the biggest myths, the idea of the smart brain. For centuries, people believed intelligence was static, that you either had it or you didn't. Ancient thinkers described the mind as a blank slate, a tabula rasa, that experience gradually wrote upon. Later, the rise of IQ tests gave us numbers that seemed to define our mental capacity, often treated as unchangeable limits. But modern neuroscience has shattered this myth. We now know that intelligence is not fixed. It grows. And the key lies in something called neuroplasticity, the brain's ability to reorganize itself, forming new connections, strengthening old ones, and even creating entirely new pathways in response to practice and experience. Every time you learn something new, your brain literally changes. Neurons fire together, strengthening their connections. Pathways that are used often become faster and more efficient, while unused ones fade. This is the essence of the phrase, neurons that fire together, wire together. If you've ever struggled at first with a new skill, whether playing piano, speaking a foreign language, or solving equations, you felt the resistance of unfamiliar pathways. But with repetition, the signals become smoother, faster, and more natural, until the once impossible becomes second nature. Another important truth about learning is that it's not just about storing facts. Memory itself is an active, constructive process. The brain doesn't hold information like a computer. Instead, it rebuilds knowledge each time you recall it, weaving new context and associations into the memory. That's why strategies like retrieval practice, testing yourself rather than just rereading notes, are so powerful. They force the brain to reconstruct knowledge, strengthening those neural connections. Spaced repetition, where you revisit information over increasing intervals, also takes advantage of how memory consolidates over time. These techniques don't just make you remember longer. They make learning more efficient by working with the brain's natural rhythms. But what about motivation? Why do some people thrive in learning while others struggle to stay engaged? The answer lies in dopamine, the brain's reward chemical. When you make progress or grasp a new idea, dopamine is released, reinforcing the learning pathway and giving you that little spark of excitement. This is why setting small goals and celebrating progress matters. It turns learning from a grind into a cycle of reward and motivation. The more your brain associates learning with positive reinforcement, the more it craves it. Sleep also plays a vital role. During deep sleep, your brain consolidates memories, transferring them from short-term storage into long-term networks. If you've ever struggled to learn something one day, only to find it clearer the next morning, that's the magic of sleep at work. Skipping rest isn't just bad for health. It actively sabotages your ability to learn. So when it comes to mastering skills or studying, sleep is not wasted time. It's an essential part of the process. Now, let's talk about mistakes. For many, errors feel like failure. But in reality, mistakes are some of the most powerful tools for learning. Each time you get something wrong, your brain receives feedback that helps it adjust. In fact, research shows that making an error and then correcting it leads to stronger memory than getting it right the first time. This is why a growth mindset is so critical. If you believe intelligence is fixed, mistakes feel like proof of inadequacy. But if you understand intelligence as something that grows, then mistakes become stepping stones. Embracing failure as feedback rewires not just your brain, but your entire relationship with learning. Environment and emotion also shape learning in profound ways. Stress, for instance, floods the brain with cortisol, which can interfere with memory and focus. On the other hand, positive emotions release neurotransmitters that enhance creativity and problem solving. This means your mindset and environment aren't just extras. They're central to how well your brain absorbs and applies knowledge. A supportive teacher, a curious mindset, or even a sense of play can supercharge learning by engaging the brain's natural curiosity circuits. Another fascinating aspect is the role of embodiment. Learning isn't confined to the brain alone, it's tied to the body. Physical activity, for example, boosts blood flow to the brain, stimulating the release of growth factors that promote neuroplasticity. This is why exercise has been shown to improve memory and cognitive performance. Even simple gestures, like using your hands to illustrate concepts, can anchor abstract ideas more deeply. The body and brain are partners in the learning process, constantly reinforcing each other. And then there's the social dimension. Humans are wired to learn from others. From infancy, our brains are tuned to imitation, watching faces, gestures, and actions. In groups, learning often accelerates because discussion, collaboration, and teaching others force us to refine our own understanding. Explaining a concept to someone else is one of the most effective ways to master it, because it forces your brain to organize and clarify information in ways passive study never achieves. That we also can't ignore technology. Today, we have unprecedented access to information, but access alone doesn't equal understanding. The challenge of the digital age is not just learning more, but learning wisely. With distractions everywhere, attention has become the most valuable currency. Research shows that multitasking fragments memory and reduces retention. Deep, focused practice, sometimes called deliberate practice, remains the most effective path to mastery. It's about quality, not quantity, of attention.so. How do you optimize learning in your own life? The science points to several key practices. Embrace a growth mindset, knowing that intelligence is not fixed but built. Use active recall and spaced repetition to strengthen memory. Break goals into smaller steps and celebrate progress to harness dopamine. Prioritize sleep, exercise, and positive environments to support brain health. Treat mistakes as feedback, not failure. And whenever possible, teach others. It cements your own mastery. Ultimately, the science of learning reveals something profound about human potential. We are not static beings limited by the capacity of our birth. We are dynamic, adaptable, and capable of growth far beyond what we imagine. The brain is not a container to be filled, but a network to be constantly reshaped, refined, and expanded. So the next time you struggle with a new skill or feel stuck in your abilities, remember this: your brain is not fixed. It is a living, changing supercomputer that thrives on challenge, error, and persistence. Learning is not about being naturally smart. It's about working with the biology of growth. And once you understand how your brain learns, you hold the key to unlocking your full potential. Because at the end of the day, the greatest secret of the science of learning is this: your potential is never finished. With every experience, every practice, every mistake, and every breakthrough, you're not just learning, you're building the very structure of your mind.
If you find this video informative, please hit the like button, subscribe this channel, and feel free to share your comments.